All right, now, sometimes they'll ask you just to determine if an argument, is valid or not. And you could, so to do that, you could see if it fits one of the common argument forms. And if it does, you should be able to tell whether it's valid or not once you recognize the structure of the argument. Sometimes they'll make you do it that way. So they'll make you say, is this, which argument form is this? And is this argument valid or not? And then other times, you're asked to determine if the argument is valid or invalid. And you just use a truth table to do that, like we did in questions 1 through 4. All right? So what I want to do is think about these argument forms we just discussed in the last video. And let's go back to the ones we did a truth table for, back here. And let's see if they fit one of those common argument forms. Okay? All right, so let's take a look at this guy. Here's the structure of the argument right here. We did a truth table and already found out that this argument was true. But now that I've talked about common argument forms, do you notice that this one fits one of those argument forms? See how it has the conditional P implies Q, and then it has P followed by Q, that same conditional. So I already know really that this one is valid, and then I'm going to give the reason. So it's valid because it's modus ponens. That P right there reminds me that that's the name for it. Okay. So if they had allowed me to, if I recognized that it fit the structure of modus ponens, then I would have already known that that's valid. Okay. All right, let's look at this guy, the second argument. So we're looking at the structure of the argument right here. So a lot of those argument forms, all of those argument forms start with P implies Q. Now here I see not Q followed by not P, which is the contrapositive. So this one is modus tollens. And I know modus tollens is valid. So this is valid by modus tollens because it fits the structure of modus tollens. Now remember earlier we did this using the truth table. We saw that it was true all the way down the line. But now we could also say, hey, it fits the structure. It is that same pattern as modus tollens. So really I already know that's valid. Okay. All right, let's look at question number 3. That's this one. Here's the structure of the argument. Q implies P. So I have my conditional P implies Q. Then I have Q followed by P. And Q followed by P is the converse. So that might remind you that this one is not valid, invalid, by fallacy of the converse. So if I had already known about those argument forms and I recognized the structure to be the fallacy of the converse, I would already know that this argument is not valid. I would already know there's going to be a value that's false. Okay, somewhere, at least one. Okay. All right, this one doesn't fit a regular argument form. That doesn't mean that it's valid or not valid. That just means I can't determine its validity by comparing it to one of the known argument forms. I just have to do a complicated truth table to figure it out. Okay? All right, so let's practice just identifying the argument forms. So that's the first thing I'm going to do. Okay? So I'm going to do that over here to the side because I might come back and do some truth tables. All right, so let's take a moment to translate this into symbols. So I see an or there. I'll buy a car, or I'll take a vacation. So P or Q. And it says I won't buy a car. So that would be not P. Therefore, I'll take a vacation, and that's going to be Q. Okay. All right, so when I look at that and I see the statement with an or, that makes me think it might be that disjunctive syllogism. And that was one of the valid argument forms. Just because it has an or doesn't make it a disjunctive syllogism. But this is the one. Like, you're going to buy a car or take a vacation, one or the other, right? And then you don't buy a car, therefore you must have taken the vacation. Okay? So this is valid, and the reason is because it has the same structure as the disjunctive syllogism. And when I give this to you on the test, you'll be able to just choose A, B, C, or D, which you'll be able to choose, and I'll already have the names there for you to select from. Okay. All right, let's translate this one into sentences. Oh, this is the example I did, sort of. If you do your homework, you'll pass the class. If you pass the class, you'll graduate. Let me get my P to look a little better. If you do your homework, you'll pass the class. If you pass the class, you'll graduate. Therefore, if you do your homework, then you will graduate. Okay. So that's the one that has that middleman that you're getting rid of. So if you do your homework, then ultimately you'll graduate. This is a valid argument form, and the reason is reasoning by transitivity. Okay. All right, let's look at C. If you do your homework, you'll pass the class. You did not do your homework, so that's not P. Therefore, you will not pass the class, which would be not Q. So it's starting with the P implies Q, like so many of those argument forms do. And then when I'm looking at this not P followed by not Q, that would be the inverse of a regular conditional. Oh, and inverse was one of the two fallacies. So this should not be valid. It should be an invalid argument. And the reason is because the structure of the argument fits the fallacy of the inverse. So what I just did with those three questions and with, going back to the problems we'd already done, is I was trying to compare the structure of the argument with one of these 6 common argument forms, because I already know that whether they're true or false, and I wouldn't really have to go and do the whole truth table. I'm going to do my last video. We'll be going back to these 3 and actually doing the truth table for them and showing you that they would have turned out the same way, that you would have determined whether they're valid or not and gotten the same answer if you had used a truth table. Now, sometimes you're given a choice. You can do either. But sometimes it specifies use a truth table. And then sometimes it specifies to try to give a reason by matching it to one of the common argument forms.